Hello and welcome to my channel. My name is Aki, and today we will look at how we can tackle pathfinding problems using a depth first search algorithm in Unity. Throughout the video, we will look at what DFS is, how DFS works, and a practice question you can try for better learning. Then later in the video, we will see a practical example of DFS in Unity. I hope you will learn something from this video. Before diving into the depth first search algorithm, let's first define the problem we are trying to solve. In many video games, particularly in real-time strategy genre, pathfinding is a crucial feature. For example, moving a unit from location A to location B seems trivial, but can be a complex task. Today, we will focus on addressing this problem. How do we move an agent or game object from point A to point B? So, what is DFS? DFS is a depth first search tree traversal algorithm that allows us to traverse through the tree until a certain goal node is reached. Specifically, in this video, DFS allows us to recursively traverse the tree and build paths so that our game object knows which path to take to reach the goal. A quick note about DFS is that DFS is also known as pre-ordered tree traversal. We will see later on what that means. DFS is not optimal, but it guarantees a path to the goal node if one exists. For optimal solution, an informed search algorithm like A* is a better choice. How does DFS work? DFS works by starting at the root node and finding its first neighboring node that has not yet been visited. Visit that first neighboring node and check if it is a goal. If not, find its neighboring node again and do the checking to see if it's a goal or not, and repeat until the goal is found. We will look at the implementation in details later, but know that DFS can be both implemented recursively and iteratively. In this video, we implemented the algorithm recursively. Let's explore DFS from a visual perspective. Imagine we're starting at the root node, labeled start or S. Our goal is to reach the target node labeled goal or G. First, we explore the left subtree of the current node. If this doesn't lead us to the goal node, we continue down the left subtree until we reach a leaf node. A leaf node is a node with no children. At this point, we backtrack and move up the tree to the parent node. From there, we explore the right subtree of the parent node. If this too doesn't lead us to the goal node, we repeat the process, backtracking further until we reach a new leaf node, or the goal node itself. This iterative process continues until we finally find our way to the goal node. Let's practice. Now it is your turn. Pause the video and try to find the path from A to E. Let's walk through the DFS algorithm step by step. We begin at node A and move to node B. From B, we head to D. Next, we visit I. Since there is no left or right child for I, we backtrack to D. From D, we go to J. Just like with I, since there are no children for J, we backtrack again to D. Since we have already visited I and J, we backtrack now to B. Finally, from B, we move to the goal node E. And so, the final path from A to E is A to B to E. Let's take a look at DFS in Unity. To implement DFS, we need to create a graph of nodes, where each node is represented by a vector 2. We also need to establish connections between these nodes or edges in order to construct or traverse the tree. Our code includes a helper function called DFS recursive helper that allows us to call the DFS function recursively. Now, let's take a closer look at the DFS implementation. We begin by starting at the start vertex and adding it to the visit node. We also build the path as we go along. If the start vertex is not our goal node, we then find its first neighboring node and recursively call the function until we reach the goal node. When backtracking occurs, we need to ensure that any invalid paths that were added during the recursive calls are properly removed. This class utilizes the graph class and constructs a tree structure. Each node in the graph is connected with 4 different nodes: left, right, up, and down, within the confines of 5 by 5 grid. The public static DFS function provides an entry point to call the graph-related functionality from another script. You will see it later. This class enables the player to move in every update cycle At the script's initialization, it calls the DFS function, as I previously mentioned, which returns a list of vectors path for navigation. In each update iteration, we check if the player has reached the last vector point on the path. If so, we calculate the direction, find the next point along the path, and move the player to that point. The player is considered to have reached the next point when the distance between them and the next point is less than 0.01. In this demo, you can see DFS in action. As expected, DFS successfully finds a path or solution from the starting node to the goal node. While DFS doesn't necessarily find the shortest path, it is guaranteed to find a solution if one exists. This means that even if the algorithm does not find the optimal or most efficient path, it will still be able to guide the player from the start to the goal. Let's recap. We can solve the pathfinding problem by utilizing a depth-first search algorithm. DFS is a tree traversal algorithm that traverses through the tree until a certain goal node is reached. While it may not be optimal, it guarantees a path to the goal node if one exists. DFS works by starting at a root node and finding its first neighboring node that has not yet been visited, recursively visiting that first neighboring node until the goal node is reached. Thank you very much for watching. I hope you found the video informative and helpful. I hope you learned something from the video, and hopefully you can apply this concept to your own project. Until next time, have a great day. Bye bye.